Here is another question. Calculate the pH of solution prepared by dissolving 49 gram of H2SO4 in ml of its solution. Solution is prepared in ml and 49 gram of H2SO4 is taken. To find the pH value, the hydrogen ion concentration must be in moles per liter. Therefore, to find the hydrogen ion concentration in moles per liter, H2SO4 also must have the concentration in moles per liter, that is molarity. To find the molarity, formula is given weight of H2SO4 into 1000 by molecular weight of H2SO4 into volume in ml. So directly find the another formula. 49 gram present in 1000 ml, that is, it is 1 liter, it is gram per liter. It is a gram per liter is 49. This much gram is present in 1 liter, that is called gram per liter. And molecular weight is 98. Therefore, we know that gram per liter equal to molarity into molecular weight. Molarity. Therefore, molarity will be gram per liter by molecular weight. You will get the same answer, 49 divided by 98, 0.5 molar. Okay. After finding the concentration of H2SO4 in molarity, now we can find the concentration of H plus ion. H2SO4 completely ionized to 2H plus and sulfate ion. 1 mole of H2SO4 when dissolved in water, it produces 2 mole of H plus. But here only 0.5 mole of H2SO4 is dissolved in 1 liter. Therefore, H plus ion will be 2 into 0.5. Concentration of H plus ion is 1 mole per liter. This H2SO4 solution is prepared in water. Therefore, from water, H plus gives 10 to minus 7 moles per liter at 25 degrees centigrade experimentally. If you compare these two value, this is H plus from H2SO4 and this is H plus from water. If you compare the value, this value is very higher. That's why in these terms you can neglect this. Net concentration of H plus is 1 mole per liter. Therefore, pH equal to minus log hydrogen ion concentration minus log 1. Log 1 is 0. The pH of solution will be 0. Here is another question. 10 to minus 2 mole of KOH is dissolved in 10 liter of its solution. What is the pH of solution? Here again, the concentration of KOH is not given in terms of molarity. You can find the concentration of KOH in terms of molarity. Molarity will be number of moles by volume in liter. Number of mole is 10 to minus 2, volume is 10, the value will be 10 to minus 3. KOH when ionized, it gives K plus and OH minus ion. 1 molar KOH gives 1 molar OH minus. 10 to minus 3 molar KOH gives after ionization 3 molar. It is strong electrolyte, that's why it ionizes completely. Concentration of OH minus is 10 minus 3 moles per liter. Water also gives OH minus ion concentration 10 to minus 7 moles per liter. But in comparison to concentration of OH minus from KOH, concentration of OH minus from water is very lower. That's why if you add this value with this, there is no significant change. Therefore, net OH minus is 10 to minus 3 moles per liter. Therefore, since OH is given, we can find POH. The POH value will be minus log OH minus log 10 to minus 3. The value will be 3. But we have to find the pH value. Therefore, pH plus POH is 14. If you calculate, the pH will be 14 minus 3, that is 11. Here is another question. 10 cc N by 2 HCl, 30 cc N by 10 HNO3, 60 cc N by 5 H2SO4 are mixed together. Acid, acid, acid. It also gives S plus, it also gives S plus, it also gives S plus. When these three acids are mixed, the solution will be acid. The resultant solution has H plus. Therefore, when you mix these three acids, the mixture acid has different concentration than this concentration given, but the mixture contains only H plus ion, and that H plus ion gives pH. Then how to find the pH of such question? First of all, find when you mix these three acids, what will be their strength, what will be their normality. And we know that normality of acid is the concentration of H plus ion in moles per liter. Therefore, for HCl, V1 is 10 cc, N1 is N by 2, 0.5 normal. For HNO3, V2 is 30 cc, N2 is N by 10, 0.1. For H2SO4, V3 is 60 cc, N3 is N by 5, 0.2 normal. After mixing these three, the volume of mixture will be 10 plus 30 plus 60, that is 100 cc. 10, 30 plus 60. Therefore, mixture, normality of mixture will be what? We know the formula: volume of mixture, normality of mixture equal to V1 N1, V2 N2, V3 N3. Number of gram equivalent of this all are added, because this does not react with each other. Normality of mixture will be V1 is 10 into 0.5, V2 is 30 into 0.1 plus V3 is 60 into 0.2, and volume of mixture is 100. The normality of mixture will be 0.2 normal. The normality of mixture is the concentration of acid H plus ion in moles per liter. This is the H plus from acid. From water, H plus is 10 to minus 7. That's why you can neglect that value. pH will be negative log of hydrogen ion concentration minus log 0.2. The answer will be 0.698. Here is another question. 2 liter of 1 molar HCl is mixed with 1 liter of 1 molar NaOH. It means this is acid and this is base. When acid and base react, they neutralize each other. H plus is neutralized by OH minus and OH minus is neutralized by H plus ion. Then calculate the pH of resulting solution. After neutralization, it may be acidic or basic. Let's see how to calculate. And also calculate the strength of the salt form. After neutralization, it forms salt and water. The reaction is HCl plus NaOH react to gives NaCl plus H2O. This is the reaction. Salt is formed. HCl and NaOH is neutralized with each other. In this reaction, you can easily find 1 mole of HCl completely neutralize 1 mole of NaOH. 1 mole of HCl completely neutralize 1 mole of NaOH and to form 1 mole of salt. The reaction is already balanced. Sometimes reaction is not balanced. You have to balance the reaction in such question when you use the concept of mole. Now to find the number of mole of HCl, you have given volume of solution and molarity. Therefore, for HCl, volume is given 2 liter. It is already given in liter. If not, then change into liter, ml into liter. Molarity M1 is 1 molar. Therefore, number of moles of HCl is V1 into M1. Volume in liter and molarity when multiplied, you will get what? Number of moles. Volume is 2 and molarity is 1. Number of mole of HCl is 2. Similarly, for NaOH, volume is given 1 liter. 1 liter is given and molarity is given 1 molar. Number of moles of NaOH is V2 into M2 is equal to 1 because volume is 1, molarity is 1. It means 2 mole HCl and 1 mole of NaOH given. From this reaction, 1 mole of HCl neutralizes 1 mole of NaOH. 1 mole of NaOH is only neutralized by 1 mole of HCl, but you have given 2 mole of HCl. Therefore, number of mole of HCl is excess than number of mole of NaOH. After neutralization, number of moles of after neutralization, number of moles of HCl left in when 2 and 1 liter volume is added. 2 liter HCl and 1 liter NaOH is added, the volume becomes 3 liter, and this 1 mole of HCl is left in 3 liter. In 3 liter is 2 minus 1, that is 1 mole. Therefore, molarity of the resulting HCl solution is, the molarity formula is volume, number of moles by volume in liter. Number of mole is 1, volume is 3. The molarity will be 0.3333 molar. Now HCl on ionization gives H plus NCl minus. The solution is now of HCl because NH is completely neutralized and the HCl is left there, and the concentration of HCl solution is 0.333 molar. 1 molar HCl after complete ionization given 1 molar H plus ion. 1 mole of HCl gives 1 mole of H plus ion, but the resulting solution has 0.3333 moles of HCl in 1 liter molarity, and from this concentration H plus is also 0.3333 and so on molar. Now concentration of H plus from acid is 0.333 moles per liter. This concentration of H plus from water is 10 to minus 7 moles per liter. This is from water, this is from HCl. If you compare this value, this is very lower value. That's why if you add these values to this value, there is no significant change. Therefore net concentration of H plus ion is 0.3333 moles per liter. Therefore pH will be minus log H plus ion minus log 0.3333, the value 0.47. When 1 mole of HCl and 1 mole of NaOH is completely neutralized, 1 mole of NaCl is formed. Here limiting reagent is NaOH. When after neutralization of NaOH, the reaction stops and the concentration of NaCl form is 1 mole in 3 liter after mixing. Therefore number of moles of NaCl formed in 3 liter is 1 mole. Therefore molarity of NaCl is number of moles by volume in liter. Number of mole is 1, volume is 3. The molarity of NaCl salt is 0.333 molar. Okay, similarly it is a one question. 0.41 gram of sodium hydroxide is placed in 100 ml of 0.1 normal H2SO4. Find the pH of resulting solution. Here is base and this is acid. When acid and base react, they neutralize with each other. The reaction is NaOH plus H2SO4 gives Na2SO4 plus H2O. Equivalence here is 2 and here is also what? 2. 2 mole of NaOH react with 1 mole of H2SO4 to gives Na2SO4 and 2H2O. 1 mole of H2SO4 neutralizes 2 mole of NaOH. From this value you have to first find the number of moles, and from the number of moles you can easily find which is left, either NaOH left or H2SO4 left. For NaOH weight is given 0.41 gram. So therefore number of moles can be calculated by given weight by molecular weight. Molecular weight of NaOH is 40, sodium 23, oxygen 16, hydrogen 1. That's why 0.41 divided by 40, number of mole is 0.01025 moles. For H2SO4, the volume is given and normality is given. To find number of mole, there is a one formula: volume in liter and molarity. Volume is given in ml, changed into liter, that is 0.1 liter divided by 1000, and normality is given 0.1 normal. To find the number of moles, there is a formula: volume into molarity. Now change it into molarity. Molarity equal to normality by N. N is basicity. For H2SO4, N equal to 2. Basicity, 2 replaceable hydrogen. That's why N equal to 2. 0.1 divided by 2. Molarity is 0.05. Number of mole of H2SO4 is volume 0.1 and molarity is 0.05. If you multiply this, you will get 0.005 moles. Now from this relation we can find 1 mole neutralizes 2 mole. 1 mole of H2SO4 neutralize 2 mole NaOH. Therefore 0.005 mole of H2SO4 neutralizes 2 into 0.005, that is 0.01 moles. Only 0.01 mole of NaOH is neutralized from this given number of moles. Given mole of NaOH is higher than number of mole of NaOH neutralized. Therefore, after neutralization, number of moles of NaOH left in, when you add NaOH in H2SO4, the volume of H2SO4 is what? 100 ml or 0.1 liter. Therefore, solution is 0.1 liter. In 0.1 liter is 0.01025 minus 0.01, that is 0.00025 moles of NaOH is left in 0.1 liter. The solution is of NaOH, that is basic. The concentration of NaOH, molarity of NaOH now becomes number of moles by volume in liter. This is the formula to calculate molarity. Number of mole is 0.00025 and volume is 0.1. The value will be 0.0025 molar. This is the molarity of NaOH. Now NaOH gives to Na plus and OH minus. Since it is strong electrolyte, it ionizes completely. If 1 mole is dissolved, 1 mole of OH minus is formed. Here the solution has molarity 0.0025 molar, that is this much mole of NaOH dissolved in 1 liter. Therefore OH minus is also formed 0.0025 moles in 1 liter. Concentration of OH minus is this, therefore 0.0025 moles per liter. OH minus also come from water. It is 10 power minus 7 moles per liter. From water, this value is negligible in comparison to this value. Therefore, net concentration of OH minus is nearly equal to 0.0025 moles per liter. Hence, since OH minus concentration is given, we have to find the POH first. POH is what? Minus log hydroxide ion concentration minus log 0.0025. The value will be 2.6. Now you have to find the pH. pH is 14 minus POH, because pH plus POH is 14. Therefore, 14 minus 2.6 is 11.4. Here is another question. 200 ml of an aqueous solution of HCl having pH equal to 2. HCl has volume given and pH given, molarity is not given. From this pH, hydrogen ion concentration can be found, and from the hydrogen ion concentration of molarity of HCl can be found. Is mixed with 300 ml of an aqueous solution of NaOH having pH equal to 12. From this pH, we can easily find the POH. From the POH, we can find the concentration of NaOH. What will be the pH of resulting mixture solution? Okay. During reaction, HCl is acid, NaOH is base. Acid and base neutralize with each other, like that. NaCl plus H2O. 1 mole of HCl always neutralizes 1 mole of NaOH. If you are able to find the number of mole of HCl and NaOH, we can easily find which is neutralized and which is left over. To find the number of mole of HCl and NaOH, volume is given. Volume of HCl, volume of NaOH is given. Therefore, there is one formula to find the number of mole is volume should be in liter and concentration should be in what? Molarity. Therefore, our first target is to find first molarity of HCl from this pH. pH is 2. Concentration of H plus is anti-log minus pH. Anti-log minus 2, the concentration of H plus is 10 to the minus 2 moles per liter. This concentration of H plus is the concentration of HCl. How? Let's see. HCl is a strong electrolyte. It ionizes completely to H plus and Cl minus when kept in water. 1 mole of HCl when kept in 1 liter, it ionizes to 1 mole of H plus. That is, concentration of H plus and concentration of HCl is same. Since here the concentration of H plus is 10 to minus 2 moles per liter is molarity, the concentration of HCl should be 10 to minus 2 moles per liter. Molarity of HCl M1 equal to 10 to minus 2 molar, and volume of HCl V1 equal to 200 ml, change into liter 0.2 liter when divided by 1000. Therefore, number of moles of HCl is volume in liter into molarity. This is the formula to find number of moles. Volume is 0.2, molarity is 10 to minus 2. The value will be 2 into 10 to minus 3 moles of HCl. Similarly, we can find the number of mole of NaOH. For NaOH, pH is given 12. From pH we can't find the hydroxide ion concentration, because hydroxide ion concentration will give concentration of NaOH. Therefore you have to find the pOH. pOH is what? 15 minus pH, that is 14 minus pH, 12 equal to 2. Concentration of OH minus is anti-log minus pOH. If you put the value here, you will again get 10 to the minus 2 moles per liter. Similarly, NaOH, when it ionizes to Na plus and OH minus, it is strong tide, it ionizes completely. The concentration of OH minus is the concentration of NaOH. Therefore, molarity of NaOH is 10 to the minus 2 molar, and volume is 300 ml, change into liter 0.3 liter. Therefore, number of moles is V2 volume in liter into molarity, 0.3 into 10 to the minus 2, that is 3 into 10 to the minus 3 moles. If you compare the value of number of mole of HCl and number of mole of NaOH, the number of mole of NaOH is greater than number of mole of HCl. It means 1 mole of NaOH neutralizes only 1 mole of HCl. 1 mole of HCl neutralize 1 mole of NaOH. 2 into 10 to the minus 3 mole of HCl neutralizes 2 into 10 to the minus 3 mole of NaOH. It means from 3 into 10 to the minus 3 moles, only 2 into 10 to the minus 3 mole of NaOH is neutralized. The excess amount of NaOH is left after neutralization of HCl. The solution is of NaOH, that is basic. Therefore, number of moles of NaOH left in, now after mixing 300 ml of NaOH, 200 ml of HCl, the total volume becomes 500 ml. That 500 ml when changed to liter, the volume will be 0.5 liter, is 3 into 10 to minus 3 minus 2 into 10 to minus 3. The value is 10 per 1 into 10 to minus 3. This much mole is left in 0.5 liter. Why 0.5 liter? When 200 ml HCl and 300 ml NaOH, when both are mixed, the volume becomes 500 ml. Now, the solution is of NaOH. Therefore, molarity will be, molarity of NaOH is number of moles of NaOH in solution by volume in liter. How much mole of NaOH is left? That is 1 into 10 to the minus 3 and volume is 0.5. The molarity of NaOH is 0.002. NaOH gives Na plus and OH minus after complete ionization. 1 molar NaOH, that is 1 mole of NaOH in 1 liter gives 1 mole of OH minus after neutralization. Here the solution is 0.002 molar, that is 0.002 moles of NaOH is dissolved in 1 liter. The OH will be also 0.002 moles in 1 liter, because it ionizes completely since it is strong electrolyte. Now here you have given concentration of OH minus 0.002 moles per liter. Therefore, pOH will be negative log of hydroxide ion concentration. Here we do not consider the OH from water, because OH from water is 10 to minus 7 moles per liter, which is very from water, which is very low with comparison to this value. That's why you can neglect this value. Minus log 0.002, the value will be 2.69. Therefore pH is 14 minus POH. 14 minus 2.69, the value will be 11.31. Calculate the pH of a saturated solution of magnesium hydroxide. The solubility product Ksp of magnesium hydroxide is this much, 8.9 into 10 to minus 12. Ksp solubility product principle is applied for sparingly soluble salt. Sparingly soluble salt like magnesium hydroxide and other. To find the solubility, to find the pH, you have to know the concentration of hydrogen ion concentration in moles per liter. Since it is base, it will give OH minus. OH, from the OH minus we can find POH. To find the POH, you must know the concentration of hydroxide ion concentration. The molarity of magnesium hydroxide is not given. Ksp is given. From this Ksp, it is sparingly soluble salt. From this Ksp value, we can find the solubility of magnesium hydroxide, and the solubility of magnesium hydroxide will give the concentration of hydroxide ion. Magnesium hydroxide is a sparingly soluble salt. It is slightly soluble in water. Whatever the magnesium hydroxide is soluble, it completely get ionized into Mg++ and 2OH minus. It is strong electrolyte, completely ionized. Lead solubility is S mole per liter. If it dissolve, it gives 2S double. 1 mole, when 1 mole it dissolve, it gives 2 mole. When S mole is dissolved in 1 liter, it gives 2S mole per liter. Now you have to find the solubility of magnesium hydroxide from the Ksp, and it gives S mole per liter. Therefore, from the Ksp relation, the value will be concentration of Mg++ into concentration of OH minus square. Concentration of magnesium is S, concentration of OH minus is 2S square, that is 4SQ. This is the type of AB2 salt, AB2. In this case, you can directly find the solubility by relation cubic root of Ksp by 4. The Ksp is given 8.9 into 10 to minus 12 divided by 4 cubic root. The value solubility will 0.00020 moles per liter. The concentration of OH minus is 2S, twice the solubility, that is 2 into 0.00020. The value will be 0.00041 moles per liter. In comparison to the OH from water, it is very high. That's why POH will be minus log hydroxide ion concentration. Minus log 0.00041, the value will be 3.38. Hence, pH is 14 minus pOH and the value is 10.6 pH value.